Hi friends, you're welcome. In today's lecture, we'll talk about AWS DynamoDB, the NoSQL type of database. Let's get started. Guys, in traditional applications, we use Relational Database Management System, RDBMS, where we design database with a strict schema, like we establish a table, we create set of tables, and we segregate data, related data in separate tables, avoid any duplications, and we identify all the keys like primary key, foreign key, and let's say we establish joins to in order to fetch the data. So this is the typical usage of RDBMS. In today's lecture, we are not talking about RDBMS. We are talking about the NoSQL, the other way of storing data. This time, the storage is not a big concern. The big concern is performance. The traditional RDBMS systems are aimed for storage optimization, where the NoSQL type of database systems are aimed for performance optimization. Agenda for today's lecture is we'll have a look at the AWS DynamoDB, the NoSQL type of database, and traditional RDBMS database, feature characteristics and differences, and then the features of NoSQL, and then we'll go to the DynamoDB console, create table and do some table operations. Let's get started. So this is a jump start tutorial. Amazon DynamoDB is a NoSQL type of database. Amazon implementation of NoSQL is Amazon DynamoDB. First of all, let us discuss about RDBMS. The key characteristics of RDBMS. This is the traditional application architecture where we use RDBMS systems, and we use structured query language SQL to insert or fetch data to query. So this RDBMS is for having the strict data modeling, where we have to set up tables and segregate related data and establish joins to fetch the data. And this is ideal for storage optimized systems, where the ideal rate or the main purpose of this having RDBMS, the RDBMS systems are mainly aimed to eliminate any duplications or redundancy. So the data can be fetched using the joins, can do any computations, aggregations. SQL is known for any sort of data fetching mechanism like aggregation, sum. There are many things are there. And performance tuning and vertical scaling. If you want to improve the performance, you can go for vertical scaling. Vertical scaling means you can upgrade the power of the CPU, RAM, storage, etc. Now let's have a look at NoSQL type. NoSQL features, they are non-relational databases. They do not support any join at all. That means all the related data is stored in the same row. They don't perform any aggregations. If you want to look for sum of quantity, no, they don't do it. And they are known for scaling horizontally. They provide consistent single digit millisecond response time. Let's say when you have a complex SQL query that return maybe in 30 seconds or 20 seconds sometimes, but DynamoDB always goes with, or NoSQL type of database always go with single digit millisecond response time. That's the key feature of having NoSQL databases. Now let us just compare SQL with NoSQL. Have a look at this table. There is a key characteristics are listed. For example, optimal workload. The relational database systems are ideal for data warehousing, online analytical processing, where you need to have SQL to create all aggregations, computations, where Amazon DynamoDB is a web scale applications. It's ideal for storing lots of data. Data model. In case of data modeling, you need to have well-defined schema in relational database systems. Whereas in DynamoDB, you don't have to mention any schema. It's just a schema less. You just need to identify, set up the primary key. That's it. You can pass any attributes in DynamoDB. Data access. In case of data access, you have to use SQL for traditional RDBMS. You know, the SQL is relational database rich set of tools simplifying development of data driven applications. But in DynamoDB, the DynamoDB provide API to do all sort of things. Still, you can use the DynamoDB provide particular SQL style of writing scripts. So the way you write, you pass the string like SQL type, SQL similar to SQL. So still you can do it as in a particular feature. Performance. Relational databases are optimized for storage, and DynamoDB is optimized for performance. Scaling. In case of scaling, relational databases scaling is possible vertically. You can do it horizontally, but mainly you can scale it vertically. You can increase the power of CPU or RAM, etc. But DynamoDB scale out using distributed clusters of hardware. So horizontal scaling is very good in DynamoDB. Now let us discuss about Amazon DynamoDB. Amazon DynamoDB is serverless. That means you don't have to manage any server at all. It's a NoSQL type of database. It's a fully managed database with single digit millisecond performance. At any query, you get it in single digit millisecond. That's the power of DynamoDB. Fully managed, highly available with replication across multiple availability zones. You store data in one availability zone, but that gets replicated in other availability zones automatically. So it's highly available, fully managed. You don't have to create any database engine at all. You simply need to create table. That's it. It supports millions of requests per second and support for massive workload. The other thing, it supports events. Events means whenever you create any record, delete any record, update any record, that will create event. That event is called DynamoDB streams. So you have old value and new value, so that you can do any kind of operations, even set up any event driven applications using DynamoDB streams. The typical use cases of using DynamoDB to develop software applications, high traffic software applications, and create media metadata store. You store media files in S3, but you can store the metadata in Amazon DynamoDB. Deliver seamless retail experiences. If you have high traffic e-commerce website, and Amazon DynamoDB is the ideal data store. Get scale gaming platform. Again, for massive gaming platform will require Amazon DynamoDB as a data store. The core component of DynamoDB table. In DynamoDB, we have to set up primary key at any point of time. The data should be unique. So the primary key, you have two options. Either you go with one key or composite key, two keys. One key is primary key, partition key. Partition key means the DynamoDB stores data in partitions, several partitions. Partition is a memory location. So the partition key will uniquely identify a particular data. Or you can have another option, partition key plus sort key. So at any point of time, the table should contain the data. The table's data should be unique across all the rows. So identifying the primary key is a key thing in DynamoDB. You have two options to set up primary key. Either you go with the primary partition key or the composite key, partition key plus sort key. In DynamoDB, data is stored in partitions. So you can have a highly distributed column, highly distributed data as a partition key. Second core component, setting up indexes. If you have another column to be searched as an index, so if you want to set up as an index, then you have option like setting up as a local secondary index. This is when you create the table first time. So you can have another column to be combined with the partition key to serve as a local secondary index. And global secondary index you can set up even after you create the table, so where you can have different columns to be used as an index. Third component, DynamoDB streams. If you enable the DynamoDB streams, it will support events. Whenever any data inserted, updated, deleted, this will create events. So you can use those events as a data driven application. Especially you can use like audit logs and etc. Let us see the data type supported in DynamoDB. Scalar types or simple type, where you can store data. The types are number, string, binary, boolean and null. Second type is document type, where you have nested documents, nested attributes. Complex structure can be stored as a document type. Third one, sets, number set, binary set, etc. To create a DynamoDB table, you need to have these things. Table name, you need to specify the table name. Key schema has to be established. You need to identify the highly distributed partition key or composite key, partition key plus sort key. Attribute definitions, the data type for key schema attributes, that's the third point. And fourth point, provisioned throughput, how many reads or writes you do it per second. This is the major thing, this is the main thing in DynamoDB. You need to provide the provisioned throughput. We call it like RCU and WCU. How DynamoDB stores data? DynamoDB stores data in partitions. So what is partition? Partition is allocation of storage for a table. How DynamoDB stores data? Amazon DynamoDB stores data in partitions. So what is partition? Partition is the allocation of storage for a table backed by the SSDs. So your data will be replicated in multiple AZs, availability zones. So it's highly available. Storing data by partition key only. If you have only one partition key, simple type, you see the diagram. So there are several partitions. You are trying to insert your data, like this is the data. Animal type is dog. This animal type is a partition key that has a dog as a value. So this hash function, this is a hash typed. Partition keys are always hash type. So this will calculate the particular hash and it will identify the particular partition and store your data. Now you see the partition key plus sort key. This is a typical example. You have animal type, still a partition key which is hash type, and name is a sort key, and this is the range type. So the hash will be created to find out the particular partition that it will be stored. So you see the partition contain multiple partition, same partitions are duplicate. Animal type dog. So it's a highly distributed partition key, but along with sort key they are unique. Animal type dog, name Fido, this document is unique document. So the combination of partition key plus sort key, the data is unique. How data modeling in DynamoDB? Data modeling style, everything in a single table. So you put all related data in single table. The only thing you need to do, you need to identify the primary key, partition key plus sort key. The other things, no issue at all. You can put any data. You don't have to worry about the schema. Multiple tables. Still, if you want to store in two tables, if you want a small join is possible, have a look at this table. This table have primary key, partition key, forum name, and it has several attributes. Still, the second table, if you want to refer this one, the partition key is highly distributed partition key is here. It has the related data here. Still, you can do small joins, but by default there is no join. Let us discuss about DynamoDB reads. DynamoDB supports two type of reads: eventual consistent read and strongly consistent read. Strongly consistent read is costly, where it will search all the partitions and make sure the data is right up to date. But eventual consistent read is by default option in DynamoDB. Now let us discuss about the free tier of DynamoDB. DynamoDB comes with free tier. It's 25 GB of storage per month, 25 provisioned WCUs, 25 provisioned read RCUs are available. Now let us log into the console and let us create table and set up the primary key with the partition key and sort key and create the attributes and do some table operations. Now let's create a DynamoDB table and add few items and explore the options. Now we are in the AWS management console. Here in the search box, search the service DynamoDB. You will get a service DynamoDB. Click to open it. Here you will find option to create a table, or there are many options here. Click tables and you will find option to create a table. Create table. I'm going to create a table with to store student exam information. To start with, I'm going to give the name of the table, TBL exam result. This is perfectly fine. Table name. To store the partition key. So the table should have partition key. It's mandatory to have highly distributable partition key. I'm going to keep student ID. Student ID is my partition key. And the type of the key, I will take it as a number. I also require sort key. Although it's optional, but for my table it's mandatory. I need to have set it like composite key, sort key. So the sort key will be like subject ID. The sort key will be subject ID. The type of the sort key also number. Student ID, subject ID. Table settings, I want to go with I want to explore the table, so click to customize the settings. So this table comes with there are two options. If you want to frequent access, standard access, the standard is highly recommended, or if your table will be used less frequently, then you can go with this option. This is less is cheaper than the standard. And click the capacity. Here how many writes or reads in a second will have this value. For the demo purpose, we will have like one read capacity unit and one write capacity unit. The read consistency, I want to set like eventually consistent. That's perfectly fine. So I am fine with eventually consistent. The capacity is set it like a provision by default. This is the default option. Provision on demand will support for unpredictable workload. The provision is perfectly fine for our case. Secondary indexes. You can create secondary indexes. You will be able to create secondary indexes, local secondary indexes during the table creation time, because the local secondary indexes rely on the same existing partition key. Our partition key is student ID. So you can create local secondary indexes when you create a table, but the global secondary index you can create at any point of time. Even after you create table and do some operations, you are able to create a global secondary index. For our demo purpose, we will create a local secondary index, create local index. The local index will share the same partition key, which is student ID. Now but it will have a different sort key. So that's the purpose of local secondary key. The sort key will be result. So I might be able to fetch the data based on the result, like pass or student. The student passing students or failing students. The result, the type is string, and the perfect. I'm fine with the index name. Result index. Attribute projections. Whether you want to project all the attributes or selected or only keys. So this is option for the demo purpose. We will keep all. Create index. Fine. Encryption at rest. Your data is encrypted at rest, and this will be managed by the DynamoDB. That's perfectly fine. Go and click create table button. Our table is being created. The status is currently creating. This will become active once the setup is done. Let us refresh. Yeah, now the table is ready. TBL exam result, the status is active. Click here so that we can get more information. Overview, general information. This table have composite key, partition key is student ID, and sort key is subject ID. The capacity mode is provisioned, and table status is active. Currently we don't have any items. Click here, the index tab. This section you can create global secondary indexes. You can create. There is no section to add local secondary index, only you can view it. And our local secondary index is result index, student ID, the existing partition key as a partition key, and sort key is another field, result. Monitor. This tab will have, you can see the usage, read usage, throttling, etc. All the information, setting up alarm with the help of CloudWatch, everything is here. Now click the actions menu. You will find option to create item. Click here to create item. Now we will create an item. Just toggle here to remove and have the standard JSON string, like JSON payload. You have a default values for 0 0 assigned to the keys. Student ID 0, subject ID 0. Now let us create item. The student ID, for example, is a number. I'm going to put like some random number. Subject ID, let's say I put 1. Now hereafter I provide any number of attributes. Let's say I type mark. Result. Pass. Scroll down, you will find option to create item. Your first item is being created. Student ID, subject ID. Let us create one more item. Now this student ID is different, subject ID is different, mark, $52. Result is pass again. remarks. This is my remark. Let's say there is no strict schema to to only pass a column, but you can provide any you can provide any attributes here. Okay, create item. You will find the second item also created. You will find a new column, new attribute is added. It's perfectly fine. You don't have it in the other one. Okay, so this way you can add the table from the console. DynamoDB provide API to insert, update all the CRUD operations. You can do it from the your applications through SDK. That we will see it, look into it in another video. Here I am going to explain the scan and query things. If you click here, you will find you can either scan your table or query your table. What is the difference? Scan means it will scan from all the partition, like you are scanning the entire table, so the search will be processed in every partition, which is very much costly, and don't do it. Always query option is better. In query options you are expected to provide the partition key, so you have to provide the partition key exactly 5845. For example, 5845. Click run. This way you are only going to get the items belong to particular partition. So query option is more querying is the best option in terms of when you work with DynamoDB. Never do scan operation until required. Okay, this is the difference between scan and query operation. If you look at the sections here, you will find Particle editor. What is Particle? Particle is something like, if you are familiar with a SQL type of thing, like select column name, comma, then from you can do the same thing with DynamoDB using the Particle. So it will give you the experience of SQL developer. There are various options here. Either you can do the backups or export to S3, export your data to S3 or import from S3, and various things are there. Okay, and also DynamoDB, on the top of the DynamoDB you can have a cache layer, which is DAX layer. You can set up to read sensitive applications. For example, your application is more read friendly. If you want to make your application, it's okay to provide the cached content, then it's ideal to set up DAX on the top of the DynamoDB. This we will cover in the next section. Guys, I hope you enjoyed the video. In next video, we'll have a CRUD operations against the DynamoDB database. From the application, we'll do all table operations, item level operations using the API. I will see you on the next lecture and next video. Until then, bye.